So my talk is titled Measure, Don't Guess. Observability is the key to performance tuning software delivery. I have a question for you. Have you ever done performance tuning on an application without benchmarking and profiling? Anyone? But come on, we've all done performance tuning without benchmarking and profiling. My real question is, have you ever successfully done performance tuning without doing the benchmarking and profiling first? I found a quote from the famous case against GoTo from back in 1972, and the quote is, "More computing sins are committed in the name of efficiency without necessarily achieving it than for any other single reason, including blind stupidity." Now, I know this quote is getting on a little bit, but I would still say it's fairly accurate, even these days. I used to work for a financial exchange in London. My boss was Martin Thompson, and he always used to say to us, measure, don't guess. If you're going to try and tune the performance of your application, you have to first take measurements to figure out, what your base state is and how to improve the performance. Now, he's not the only one who says this. I borrowed with consent this picture from Holly Cummins, who works at IBM. She gives a whole bunch of presentations about performance too, and she always says, measure, don't guess. And she says she stole it from Kirk Pepperdine, who's another performance tuning expert. So what if we applied the same performance engineering mindset from optimizing application performance to optimizing the developer experience? Firstly, let's take a look at the pain of the developer experience. From a Gradle point of view, I work for Gradle, from a Gradle point of view, we're often talking about the pain of waiting for builds to pass or not pass. We're talking about the pain of troubleshooting any failures that might happen. We're talking about the pain of flaky tests. This is my particular favorite. Sorry, what's the opposite of favorite? This is my particular not favorite. Flaky tests drive me insane. If you want more information about flaky tests and you didn't go to Brian's talk in the other room, have a look at it on the YouTube, because they did do extensive coverage of flaky tests. A lot of these pains tend to lead to an overloaded continuous delivery pipeline. I actually got ChatGPT to do this, and it's not dreadful. So you're going to overload your continuous delivery pipeline if you've got long builds, if you can't troubleshoot your build, if you've got flakiness in your tests. It's going to cause you trouble. And on top of that, there's always security. As a developer, I'm aware that I need to care about security, but it's always something that kind of comes a little bit later on, and in the hope that someone else can tell me what I need to do for security. There is a quick fix to a lot of these problems, and I'm sure we've all done this too. The quick fix is to throw hardware at the problem. So I wanted to find some statistics or some useful information about how often we should throw hardware at the problem. I found a quote from 2008 from Jeff Atwood, co-founder of Stack Overflow. He said, "When does it make sense to throw hardware at a programming problem? As a general rule, I'd say almost always." So he was actually talking about in the olden days, before cloud, buying a server, plugging it into a rack, and that would cost significantly less money than developer time wasted. So his argument is it's always better to use hardware to speed up a performance problem. Probably you might even argue in the age of cloud, this is even more appropriate than before because it's so much easier. But the question then is, did it fix the problem? Was it cost effective? And most importantly, how can you tell? In Hans's keynote at DPE Summit last year, he had this slide. 90% of CPUs in CI are unused, but still have queuing issues. This is clearly not a hardware problem if you have 90% of your CPUs sat around doing absolutely nothing. So we need to be able to find out where the problem really is. Found a quote from Charity Majors in the more recent past. She knows a bit about observability because she runs a company that does observability in production. "We are way behind where we ought to be as an industry. We're shipping code we don't understand to systems we have never understood." This resonates quite strongly with me. I've worked on a bunch of systems like this. And I think in the age of Gen AI, when we're not even writing the code ourselves, this might become even more important to consider. Fortunately, when we look at the continuous delivery/DevOps loop, we do have monitoring as part of this. It is important to be able to see what we're doing and how we're doing it. But often, when we look at the continuous continuous deployment pipeline, when we talk about monitoring, we're talking about monitoring performance in production. That's what we care about. What are our apps doing in production? How does that impact the users? And we don't often actually look at all of the rest of the deployment pipeline. And as I mentioned in the keynote this morning, it's not just a case of like a few boxes and a few lines. Our CD pipelines are enormously complicated, running on lots of different agents in some weird and wonderful matrix. And yet we have very little visibility over what's happening there. So what we're talking about here is we're talking about measuring the path to production in terms of developer productivity. The developers have worked on code. How quickly can you get it into production? Because otherwise, in lean terms, it's just waste. It's just sat around doing nothing. And more specifically, we're talking about observability, not monitoring. Now, until I did my research for this presentation, I actually didn't know what the difference was. And again, I have to go to Charity Majors, who said, monitoring is about known unknowns and actionable alerts. Observability is about unknown unknowns and empowering you to ask arbitrary new questions and explore where the cookie crumbs take you. This is a really important difference. With observability, you don't have to know the questions you're going to ask of your continuous delivery pipeline or your application or whatever. You can just use it to look around and see what the data tells you. So what is the solution to our pains in terms of deployment and developer experience? I've already mentioned it. If you cannot measure it, you cannot improve it. So my quotes are getting even older now. This is from Lord Kelvin in 1847. Actually, he didn't say that at all. He said something much more long-winded and more difficult to quote. But the internet turned it into this, so now this is clearly the truth. But the point is, when it comes to science, if you can't measure it, you can't improve it. So let's use science. Let's go ahead and use scientific method to improve developer experience. In fact, in Accelerate, they talk about the ability to experiment is a critical part of innovation and creating business value. We need to be able to use experimental approaches to improve the way that we work. And the scientific approach is as simple as measure, form a hypothesis, and implement a change. Implement one change, by the way, change one thing. Because I know what we all do. We get some data, we look at it and go, oh, I think I'm going to change this and this and this. And then you don't know which changes were effective. So how do you measure? That's what we're talking about, observability and measurement. Now, I work for Gradle, so I'm going to say use Develocity. Also, I hope our head of design isn't in here because he'd be really upset about what I've done with the logo. Use Develocity. Develocity will tell you a bunch of information about your builds throughout your continuous deployment pipeline. For example, number of builds, trends in build time, that kind of thing. Be able to tell you how many failures you've had over time. It talked about flaky tests, identify your flaky tests, and you can do a lot of stuff across projects, which is really helpful for your technical management. You'll be able to see things like, are there some dodgy dependencies which are used in some projects that you didn't even know were being built in CI somewhere? This can expose a whole bunch of information to you you didn't even know that you needed. And of course, because, it's 2025, we're also going to talk about using Gen AI and LLMs and be able to query the MCP server to find out information like, why did my build fail? And in fact, if you were in Laurent's talk, he talked a lot about this kind of thing. So science is a good thing to use. Your best and wisest refuge from all your troubles is in your science. And that was Ada Lovelace, who was the first programmer. So obviously, she was correct when she said this. So now you've done your monitoring, observability, measurement, what do you see? So let's talk a little bit about the sorts of things you might be able to see if you start looking in places like where your builds are happening and in your deployment pipeline. Sometimes we look at a great big build, particularly when it comes to enterprise applications, which are large, complicated, and gnarly, and often a little bit older than we would like to see. And we just assume the build is going to take a long time because it's just a lot of code. So our assumption is it's just big. That's why it takes a long time. But in actual fact, when you measure it and when you look at the details, you'll find that dependency resolution, maybe, for example, is dominating your build time. This is also from Hans' keynote last year. We found that 30 to 40% of all CI build time at large organizations is spent downloading dependencies. And that is a lot of time to do a task which should be fairly easy to speed up. The solution is quite straightforward. It's usually add a cache. If you're interested in our caching technologies, Etienne and Mirko are going to be talking about caching tomorrow. I don't remember which time, but they'll be able to talk about it in more detail. Another thing that people might comment upon is that flaky tests are occurring. And the assumption is that they just randomly fail. We can't predict why they fail. We just have flakiness in the system. But if you measure it, you might be able to identify one of many different sources of flakiness. This is kind of one of the problems with flaky tests, is that it could be any number of things. You might be able to find things like, it's just a small number of tests which are responsible for most flakiness. That gives you some focus. You can fix those tests and address those specific problems. It might be that the tests randomly fail, but the failures align with things like increased load or something which is outside of the code base. Or it might be you'll find that you get more flakiness on certain infrastructures. The thing is that you can't identify any of these problems if you're not looking for them. Flaky tests in particular are hard to fix because you have to find the problem. Most of the time, you don't even know you have flakiness. You just go, well, I'll just rerun it and it's probably fine. There was a study done on the impact of flaky tests on developer experience, and it said, our analysis revealed that rerunning the failing build and attempting to repair the flaky test were the most common actions. Okay, so far, so good. What was more interesting is they found that our findings also suggested that developers who experience flaky tests more often are more likely to take no action in response to them. So as soon as you have any flakiness in your build system, you end up losing trust in that whole build system. You lose trust in your tests, in which case you're spending a lot of time running tests for less value because your developers are ignoring the results of those tests. And of course, we always have the security stuff. So our assumption is that our pipeline is secure, it's fine, until you actually measure and take a look and you find out you have some dependency you didn't know about sneaking into some project. You might not even know that that project was being built. You can't know these things without having some kind of observability there. Without observability, you can't know that your pipeline is secure. You need to be able to see that the dependencies are the ones you expect and you don't have some weird things happening. I also wanted to bring this back a little bit to DORA, because DORA is our way to allow us to measure to see if we're actually effectively delivering the software that we say that we're delivering. So shorter builds will lead to faster lead time. Reliable pipelines will lead to higher deployment frequency. Catching your flaky tests will lower your change failure rate. Faster troubleshooting will lower your MTTR. And on top of that, the complete visibility into your build pipelines will give you the pervasive security that you need so that you're not running loads of security tests at the end and then finding out that actually you've got a big security hole. Or worse, you don't find that out. So observability is the foundation for performance, productivity, and compliance. You have to start by measuring what's there. And we used to talk about the 3 pillars of observability, acceleration, and troubleshooting, but now we sort of realize that you can't have any of the other things if you don't have observability first. So my take-homes are, if you're not already doing it, and to be honest, a lot of people in this audience probably are already doing it, but if you're not already doing it, start measuring things that matter to you today, particularly when it comes to your path to production. Because without observability, you're not able to see the state of where you started, identify potential bottlenecks, and at the end, when you've made your improvements, show that you've made positive changes. You need to start with observability. Thank you very much.